Okay, so this video is intended for my geometry students. We have a sections 10.1 through 10.3 quiz on Friday, and here's some problems to help you review for your quiz. So the first problem here says, is segment AB tangent to circle C? Okay, well, we look at this word tangent, and we think to ourselves, okay, tangent means it touches that one spot, right? That's what a tangent is. So here's that one spot, point B. Now we also have to remember that this right here is a diameter, and this right here is a radius. So we have a diameter here, right, goes to the center, and we have a radius right there. There's a theorem that says if AB is tangent, then where the radius touches that tangent, you're going to have a right angle. So the question is that a right angle? Because if it's a right angle, then AB is tangent. And if it's a right angle, then this triangle should follow Pythagorean theorem. So let's try to use Pythagorean theorem. Now, if this would be the right angle, 29 is the hypotenuse. This side, from here to there, is 10. The radius is 10. So then this to here is also 10. So that entire side is going to be 20. Don't let that fool you. And if you're confused, ask me a question. I can help you out. Okay? But that's 20. So our Pythagorean theorem says 20 squared plus 21 squared. Does that equal 29 squared? And we get our trusty calculator. We'll do 20 squared plus 21 squared. I get 841. And we'll do 29 squared, and I get 841. 841 is equal to 841, so yes, we have a tangent. Okay, so here is our next problem. I'm going to tell you that segment AB is tangent to circle C. And I want you to find the radius. All right. Well, first of all, if AB is tangent to circle C, then this radius, AC, is going to be perpendicular to that tangent at the point A. So we have a right triangle. Okay, that's going to be very helpful. Now, we want to find the radius. Let's call it X. Well, the radius is AC. And it's also somewhere else. It's from C to where this triangle hits the circle. This 8 is only the outside part. So this side, you need to combine it to make it x plus 8. Remember, it's segment addition, not multiplication. It's not 8x. It's not that. It's x plus 8. And now we're going to use Pythagorean theorem. If this is the hypotenuse, if this is the right angle, then the hypotenuse is BC. That's going to go by itself. X squared plus 16 squared is going to equal x plus 8 squared. Let's do this on the side here, or we'll do it here. Remember that x plus 8 squared is x plus 8. Here, I'll do a different color on the side, like I said. That's x plus 8 times x plus 8. It's a FOIL problem. First, outer, inner, last. FOIL. First, x squared. Outer, 8x. Inner, 8x. Last, 64. And then that simplifies to x squared plus 16x plus 64. And that guy's going to go right here. So we get x squared. 16 squared is going to be 256. Equals x squared plus 16x plus 64. Now you say, oh gosh, Mr. Chappell, this is a quadratic problem. Well, wait a minute. X squared on one side, x squared on the other side, gone. And now it's an easier problem. You need to get the x by itself. Let's subtract 64. We get 192 equals 16x, and let's divide by 16. And we get 12. So the radius equals 12. Be careful of a problem like this where you have to use the radius twice. And remember, x plus 8 squared, anything times itself, or anything squared is that thing times itself. And it's a FOIL problem. Okay, next one here. This problem is very familiar to us from our homework, but this time we're going to find the perimeter. Okay. Well, we need to remember this common tangents, tangents from a common exterior point idea. If this is x from here to here, this segment is tangent to the circle, and so is this one. They are tangent from the same exterior point. They are congruent. So this right here is also x. Okay. Now this side is 18. But we need to think about the radius. From the center to the point of tangency is the radius. That's 5. That distance travels down. So from here to here is also 5. It travels down. And these two tangents are common as well. They're from the same common exterior point. So this is congruent to that. And that leaves this to be 5 as well. And then if this is 18 and this little small part's 5, then from here over here is going to be 13. That's 18 minus 5. And again, common tangents, or tangents from a common exterior point. This is congruent to that. So this right here is 13. So now our side lengths for this right triangle, which we want to find the perimeter of, because I don't know x yet. The side lengths are x plus 13, right, all the way down, 18, and then this, I'm going to write it vertically, is x plus 5. The hypotenuse is my x plus 13 because it is across from the right angle. So I can use Pythagorean theorem. So I have x plus 5 squared plus 18 squared equals x plus 13 squared. And remember, this is x plus 5 times x plus 5. This is x plus 13 times x plus 13. You have a FOIL problem. And we have x squared plus 5x plus 5x plus 25. Plus, and then 18 squared, we'll just simplify that now, is 324. Equals, and I'm going to run out of room, so I'm going to go below. Equals, and now we're going to do x plus 13 squared. X squared plus 13x plus 13x plus 169. Now, let's simplify. You say, oh my gosh, x squared's again. Look on each side. X squared gone. So we get 10x plus 349 equals 26x plus 169. I'm going to move the 10 that way by subtracting it, right? Minus 10x, and move the 169 that way by subtracting it. So we get 349 minus 169 is 180. And 10 or 26x minus 10x is 16x. And then when you take 180 divided by 16, you get 11.25. And there's going to be the value of x. So now to find the perimeter, I need these three sides. X plus 5, x plus 13, and I know that's 18. Well, the perimeter, x plus 5, that's 16.25, plus 13 plus 11.25 is 24.25, plus, and then we have the 18 right here. And we just add those together, 16.25 plus 24.25 plus 18. Gives you 58.5, and that's the perimeter of this triangle. So remember, if two tangents to the same circle come from the same exterior point, then they are congruent. Alright, very good. That's a tough problem. Okay, here's the next problem. So I've given you a picture. I want you to find the indicated measures, and we have two arcs and an angle. And I've given you in this picture that we have a right angle for angle QRS and a 35-degree angle for angle SRT. So the first thing I would do is I would find all the other angles. Now remember, these angles are all central angles, so they are going to equal their minor arcs. Okay? Now, QSU is a half circle because QU is a diameter. So to find this angle right here, I'm going to take 180 minus 90 and 35, which is 125. 55 degrees. This angle is vertical with PRQ. 55 degrees. And then the last one, I'll put it in orange. I'll put 3 marks for it. This one right here, you have a diameter, which makes a semicircle. So it's going to be 180 minus 55, which is 125 degrees. So at this current moment, I have all my angles that I need. So now we go find the arcs. So the measure of arc QT. So QT goes from here to here. So QT contains 90 degrees and 35 degrees. QT is 125 degrees. PTU. Now PTU goes from here to to T, and all the way to U. So it's this big major arc right here. Well, it's everything but this minor arc of 125. It's the entire circle 360 minus that minor arc. That's going to be 235 degrees. And then lastly, the angle measure, PRQ. PRQ is this angle right here. PRQ is 55 degrees. Okay, so that's simply given a couple angle measures or arc measures, you can find everything you want to know about a picture. Okay. Remember, central angle equals the minor arc. Okay, so you might recall this problem from the homework as well. So here's your picture, and they tell you that YZ is 6, and they tell you that XW is 4. And the question is find XZ. So I want to know what is XZ. Okay? Well, first thing I see is I see a right angle. So I know all 4 right angles, so this is a right angle down here. So I have a right triangle that involves my question mark. This side is 4. I want to find this side, so hopefully I can find WZ. Well, we have a theorem. We have the diameter. That's bad. Use a different color. We have the diameter chord idea, if you remember that theorem, which says that if a diameter is perpendicular to a chord, which it is right here, then it bisects the chord. Boom, boom. Congruent segments. If they total give you 6, 3, and 3. And now we focus on this right triangle to find XZ. Let's call it side C, right? It's the hypotenuse, 3 squared, give me 1 second, 3 squared plus 4 squared equals C squared. 25 equals C squared. We take the square root. C cannot be negative, so it's not negative 5. It's just going to be positive 5. So XZ is 5. Okay, so remember, if a diameter is perpendicular to a chord, it bisects that chord and it bisects the arcs. So we also know that these arcs are equal in measure as well. Okay, we got 3 more questions left. So question 6 says find x. And they give you an angle and an arc. This 18x minus 32 is this entire blue arc. So that entire, I'll do it blue even more. It's this entire blue arc, that major arc. Well, this angle right here is an inscribed angle. It's going to be equal to half of its arc. So my equation is 7x. The angle measure, 7x plus 16, is going to be half of its intercepted arc of 18x minus 32. Since I can take half of 18 and 32 and get nice numbers, I'm going to go ahead and distribute that 1/2. 7x plus 16 equals, take half of each, 9x minus 16. I'm going to move the 7x this way and the 16 that way. Alright? So I'm going to subtract 7x, I'm going to add 16. 16 plus 16 is 32. 9x minus 7x is 2x. And then divide by 2. And there we go. X is 16. Now let's check real fast. 7 times 16 plus 16. That angle measure is going to be 128. So we should know that the arc should be 256. Let's see. 18 times 16 minus 32. 18 times 16 minus 32. 256. And the relationship is true for an x value of 16. Okay, my picture won't let me move, so it's there in the middle. Whatever. Find x and y is the question here. Okay, 2 more questions left. Number 7. Find x and y. Well, x and y are both inscribed angles. Okay, so let's trace their path and see where they end up. X is this angle right here. The arc that it intercepts is QR. Okay? Well, I don't know QR. Or do I? Is there another angle that intercepts QR? And yes, there is. This angle, 45 degrees. Since they intercept the same arc, they are congruent. X is 45. Similarly, we do the same thing with y. Y is here. Let's trace y. This is the arc. I don't know the arc. But is there another angle that intercepts that arc? Yes, there is. This inscribed angle. 40. So 40 is congruent to y. So y is 40. And there you go. So remember, this is that idea that if 2 inscribed angles intercept the same arc, then they are congruent. Okay. Last one. This is a goodie. I created it myself. Okay. Find x, y, and z. All right. So here's my picture. So notice that we have an inscribed polygon. I'm going to write that down. We have an inscribed polygon. Inscribed poly. I'll leave it like that. Okay. Remember, with an inscribed polygon, you know that opposite angles are supplementary. So to find x, 2x plus 134 are going to equal 180. They're supplementary. So remember that, supplementary. So I'll subtract 134 and get 46 and divide by 2. X is 23, making this angle 2 times 23, or 46. Now, let me find angle B just for the heck of it. Okay, let's just have good practice. The measure of angle B, to find angle B, let's do the same thing with the 95 degree angle. So I'll use the measure of angle B plus 95 equals 180. And I'll subtract 95 and I'll get 85. And there's those 4 angles. So again, we didn't have to find angle B, but maybe it's going to be helpful. Who knows? Okay. So now let's look at y. Y is up here. Here's y. It's this arc. Now, there is no angle that intercepts it. But there is an angle that intercepts arc BD. Wouldn't arc BD have a measure of y plus 22? And don't we know the angle that intercepts that arc? Yes, we do. It's 46. Okay, follow it. Oh, sorry, that's bad. Follow it. So this angle, this inscribed angle, is half the measure of that arc. And that's the equation we need to set up. 46 degrees, because we found it. It's not 2x, it's 46 degrees. 46 degrees is half of this arc, y plus 22. And this is how we'll find y. Now, lazy mathematician, I don't want to do 1/2 of y because I get 1/2 of y. Instead, I'm going to take this equation and multiply it by 2. The 1/2 and 2 cancel, which releases the y plus 22. On this side, we get 2 times 46, which is 92. And now I can go ahead and I can subtract. Subtract 22 from both sides, and you get y is 70. And that is a 70 degree arc. Okay, so I'll put it in blue. So this is now a 22 degree arc. We knew that. This is a 70 degree arc. Okay, just giving us more information. All right. Okay. And now Z. Well, I think we can find Z in a similar way. Again, there is no angle that intercepts arc Z, right, with the Z. But there is an angle that intercepts arc AC, which has a measure of Z plus 22. That is angle ABC. This angle right here, angle B. So lucky I found angle B, because now I can use it. I think ahead so much. 85 degrees. That inscribed angle is equal to half of that arc. Z plus 22. Now, I'm not going to multiply by a half. I'm not going to distribute the 1/2. I'm going to multiply by 2. So I'll get 170 equals Z plus 22, and I'll subtract 22. And now Z is 145. Okay. And then if I wanted to find the last arc, I could add the other ones up together. So 70 plus 22 plus 145. That gives me 237. And take it away from 360. And that would give me 123 for this arc. And there you go. Okay. So there's the video. Hopefully this helps you prepare. Again, this last problem is a good one. Okay, so make sure you pay attention to it. All this y plus 22 stuff, adding arcs together. Make sure you pay attention to that. You might see that again. All right. Thanks for watching. We'll see you tomorrow.